So in our last section, 5.5, which is U substitution, we are going to learn how to integrate two functions, but with a very specific case when one of the functions is the derivative of the other. So in this case, we can use U substitution. Now here are the steps which I'll go through with you, but take a look at them, but I'll go through these steps with you in the examples. All right, so we want to find the integral 2x plus 7 times x squared plus 7x plus 7 to the fourth power. Now notice that we can't use the power rule of integrals for this because we have a multiplication problem. And if you try to take x squared plus 7x plus 7 to the fourth power, you're going to have to take x squared plus 7x plus 7 multiplied 4 times. And as you can tell, that's going to be a pain in the butt. So I guess you could use the power rule, but you have to multiply all this out and then multiply that by 2x plus 7. And then from there, you would have to try to write the integral. Way too much trouble, right? Way too much trouble. So we're not going to use that method. So instead, we're going to use U substitution. So how does it work? Now the steps are on this previous page, but it says rewrite one of the functions in terms of U. So this will always be the function with the higher exponent. So the U, if you want to know how do I determine which one's U is always going to be the function with the higher exponent. So in this case, the higher exponent is x squared plus 7x plus 7, and that'll be equal to U. Now, we're not going to take the whole thing to the fourth power. U is just going to be the internal function, which is x squared plus 7x plus 7. Now, how does that help us? Because if you take du, the derivative of U, it's going to be 2x plus 7 times dx. Now make sure that dx is there because we're taking this derivative with respect to x. Okay, so now we can rearrange this. So I'm going to take the x squared plus 7x plus 7 to the fourth power, and then I'm going to move the 2x plus 7 and dx together. Why do I do that? Because notice that du is equal to 2x plus 7 dx. So by moving them together, I now have a du. And I also know that u is x squared plus 7x plus 7, so I'm going to replace the u with x squared plus 7x plus 7. I'm going to do a substitution. And then this whole thing is going to be du, which is the derivative of the internal function, x squared plus 7x plus 7. So now I have the integral of u to the fourth du. And anytime I integrate, whatever I'm taking the integral of, we have to have the same variable when it comes to the du, or dx or whatever it is. Okay, so these two have to match. Now we can apply the power rule of exponents. So the integral of u to the fourth is going to be u to the fifth over 5, according to the power rule of exponents, the n plus 1 over n plus 1, then you got the plus c. And finally, I want to go back in the x world because I'm originally integrating with respect to x. So I'm going to replace the u with x squared plus 7x plus 7, so that I have that to the fifth power over 5 plus c. So notice how this is going to be a million times easier than having to multiply all of this out. So the trick here is to let the higher exponent be u. When you take the derivative, you will be, all these problems are set up so that the derivative will equal to, or the second function will be the derivative of the first function, and then you can do your u substitution. Okay, let's take another example. Oh, and you can check this. So if I take the derivative of x squared plus 7x plus 7, here's what happens. The 5 comes down. So I have 5 times x squared plus 7x plus 7, and I subtract 1, so that'll be to the fourth power. But from the chain rule, because a parentheses contains another function, I have to multiply by the derivative of that, which is 2x plus 7. Now the 5 and 5 cross out, so I have x squared plus 7x plus 7 to the fourth power times 2x plus 7. That's exactly what the original function was that we're trying to integrate. Okay, here's another example. You want to find the integral of this function. So remember, u is always going to be the one with the higher power. The higher power is x to the fourth minus 6. So our u is going to be x to the fourth minus 6. That's our u. Okay, now du, the 4 comes down, so it'll be 4x to the third times dx. And notice I have an x to the third dx, but I don't have a 4. So here, so we're going to have to change things a little bit because I have an x to the third dx, but I don't have a 4 in this. So because we're missing a 4, I have an x to the third dx here, but I don't have a 4. So what I'm going to do is I'm going to isolate the x cubed dx because that's what I have. So I'm going to isolate that. So how do I isolate it? Well, I just divide both sides by 4. So x cubed dx, which is what I have, is equal to 1/4 du because it's du over 4. So you can write that as 1/4 du or du over 4. It's up to you. But I want to isolate whatever I have in the integral. So now I can say x to the 4th minus 6 to the 22nd power. X to the 4th minus 6 is u, so I have u to the 22nd, times x cubed dx. What is it equal to? It's equal to 1/4 du, so I have a 1/4 du. And because it's a constant, I can just take the 1/4 out. So now I have u to the 22nd du. Now things are easy. This is going to be u to the 23rd over 23 plus c. I replace u, and then 4 times 23 is 92. I'm just multiplying. And I replace u with what it equals to originally in terms of x, which is x to the 4th minus 6. So I have x to the 4th minus 6 to the 23rd power over 92. So again, I want to get the x cubed dx by itself. So the 4 has to move to the other side. And then I just replace x cubed dx, this whole thing, with 1/4 du, which is what it equals to. The check is optional, but I'm doing the check just to show you guys that it is the same thing. So remember, the integral is going to be the opposite of the derivative. So if I take the derivative of my answer, the 23 comes down. So I have 23 x to the 4th minus 6, and I subtract 1, so it'll be to the 22nd power. And then I have to multiply by the derivative of the parentheses, which is 4x cubed. Then 23 times 4 is 92, so those cross out, and I'm left with x to the 4th minus 6 times 4x cubed. Oh, sorry, I forgot the 22 here. And I'm sorry, this 4 isn't there because I multiplied the 4 and 23. So I have x to the 4th minus 6 to the 22nd times x cubed, and that's exactly what my original function was. So the check, it makes sense. Okay, next example. Oh, and then here's a reminder of the integrals of trigonometric functions. Let's find the integral of secant 2x tan 2x dx. So from the trig integrals, the integral of secant x tan x is equal to secant x plus c. So what I have is, I have a secant x tan x, but I have a 2x in the parentheses and not an x. So I can't use that yet because I have a 2x. So I have to do a substitution. So my u is going to be whatever's in the parentheses, which is going to be 2x. And then du is going to be 2dx because the derivative of 2x is going to be 2. However, I don't have a 2 here. All I have is a dx. So to isolate that, I'm going to divide both sides by 2. So dx is equal to du over 2. Now I can substitute. So instead of 2x, I can write that as secant of u tan u. And then instead of dx, I'm going to replace that with du over 2. Now the integral of secant u tan u is just going to be secant u plus c. And then the 1/2, divided by 2 is same thing as saying a 1/2. So that 1/2 comes out. I have 1/2 secant u plus c. And then at the end, I just have to replace the u with a 2x. So once again, the reason that I couldn't integrate this is because I don't have a secant of x tan x. I have a 2x. So I need to get that 2x just as one term, which is why we do the u substitution. And because we do a u substitution, I have to replace the dx by du over 2. And du over 2 is same thing as just pulling out a 1/2. Okay, here's another question. I have the integral of 9 sine x to the 5th power times cos x dx. So remember, the u is always going to be the higher power. So my u is going to be sine x. Now, not sine x to the 5th. It's just going to be the base term of that. So my u is just going to be sine x. Now du is going to be the derivative of sine, which will be cos x dx. Okay? So what do we do with this? Well, I have a cos x dx, so I have exactly what I need. So I just have to replace the sine x with u. So I have the integral of any constant you have, you pull it out. Remember, sine to the power of 5x is same thing as sine of x to the fifth power, and sine of x is u, and then cos x dx is du. So it works out really well for us. So I have 9 times the integral of u to the fifth du. The integral of u to the fifth du is going to be u to the sixth over 6 plus c. Don't forget the constant of integration, and then if you simplify that, that'll be 3/2. Replace the u again with sine x, so I have 3 sine of x to the sixth over 2 plus c. We can do a check. So if I take the derivative of my answer, 6 times 3 is going to be 18, and I subtract 1, which is going to be 18 sine x to the fifth power times the derivative of the parentheses, which is cos x, by the chain rule. 18 over 2 is 9, and that's exactly what I had to begin with. 9 sine x to the fifth power times cos x. So checks out. But again, the check is completely optional. All right, here's another example. We want to find the integral of x squared times the fifth root of x cubed plus 6. So u is always going to be the term with the higher power, but just the base term, not the fifth root. So u is going to be x cubed plus 6. And then the derivative of x cubed plus 6 is going to be 3x squared dx. So let's rewrite this. I have the fifth root of x squared plus 6 times x squared dx. So notice that I have an x squared dx, but I'm missing a 3. So I need to isolate the x squared dx in this du. So I divide both sides by 3 because I just want to solve for the x squared dx so I can substitute just that part. So now I have u, which is x cubed plus 6, and the fifth root is same thing as power of 1/5. This is going to be 1/3 du, so I can pull the 1/3 out. So I have 1/3 times the integral of u to the 1/5 du. Now I can use my power rule, which is the u to the n plus 1 over n plus 1. Remember, when you add fractions, you need a common denominator. So the 1 over 1, you can write that as 5 over 5. So we get u to the 6 over 5 over 6 over 5. We can't divide by a fraction, so instead we multiply by the reciprocal, which is 5/6. And then that'll give you 5 over 18, u to the 6/5. But u has to be replaced with our original term in terms of x. So we have 5 over 18 times x cubed plus 6 to the 6/5 power plus c. Okay, here's another example. Remember that the higher exponent's always going to be the u. So we have u is equal to x to the 6th plus 5, which means du is going to be 6x to the 5th dx. Okay, now let's rewrite this. So anytime you have a term on the denominator, we have to move it to the numerator. So I'm going to write this as x to the 6th plus 5 to the negative 6th power times x to the 5th dx. Now notice I don't have a 6 here. So I need to isolate x to the 5th dx in this equation here. So I divide both sides by 6, and I get x to the 5th dx is equal to 1 over 6u. Okay, so now I have my u, which is x to the 6th plus 5 to the negative 6th power. So it's u to the negative 6th. And then x to the 5th dx, we can replace that with 1 over 6 du, because that's what it equals to. So I have u to the negative 6th times 1/6 du. I can pull out the 1/6. Now I have set this in terms of just u du, so I can use the power rule of exponents. And that'll be negative 6 plus 1, which is negative 5 over negative 5 times 1/6. If I multiply 6 and negative 5, that'll be negative 30. And then anytime you have a negative exponent in the final answer, it needs to go back to the denominator. So I replace the u with x to the 6th plus 5, and then that's going to be to the 5th power, which I left out here, looks like. So that'll be my final answer here. Okay, please copy this down and I'll go over this in class with you guys. Actually, for some reason, I'm being able to record past 15 minutes, so I'm just going to go over it. Sorry about that. All right, so this time we got the same thing, except we have a definite integral from -2 to 1. So u is going to be 6x plus 2. It's always the highest exponent. And then du is going to be 6dx. I don't know why it's letting me record past 15 minutes, but it's pretty cool. But remember, I want to isolate the dx. So because that's all I have here. So my dx is going to equal to 1 over 6 du. Now the 30 is a constant, so I'm going to pull it out eventually. But I have 30 times, this is my u, so I have u to the 4th, and then dx is equal to 1 over 6 du. And now I have 30 times 1/6, which I can simplify to be 5. So I have 5 u to the 4th du, and now I can pull the 5 out, not the 30, because it gets simplified. So I have 5 u to the 5th over 5 plus c, and then that's going to be from -2 to 1. Those are my limits of integration. And so if I cross that out, it's going to give me u to the 5th plus c. My limits of integration are -2 plus 1. But I need to be in terms of x, which is 6x plus 2. So I have 6x plus 2 to the 5th power plus c from -2 to 1. The first fundamental theorem of calculus tells me that this is equal to f of b minus f of a. So what I recommend is just go to desmos.com, and in desmos.com put in f of x equals to 6x plus 2 to the 5th power. You don't need to put in, this is a, I don't know what's happening, I'm sorry. This is a 5 and I can't write that. So I'm just gonna ignore it, ignore that. Just go to desmos.com and put in this function 6x plus 2 to the 5th power. You don't have to put the plus c. And then from there, you can just do f of 1 minus f of -2. Or you can just do it by hand by replacing the x's with 1, then the x with -2, and do f of b minus f of a. But doing it on Desmos is a lot easier. And we get 132,768. And again, on Desmos, here's what that would look like. So you'd go to desmos.com, and then you would put in your function, right? So your function f of x is going to equal to 6x plus 2 to the 5th power. Don't put in the c because it's going to cancel out anyway. And then from there, we're going to have f of b. So the higher one is 1. So I have f of 1 minus f of -2. And then it just makes your life a lot easier. Or again, like I said, you can do it by hand if you really wanted to, but there's no reason to do it by hand. And that's it. We're done with Calculus 1. Congratulations.